Okay, we're going over the pretest practice and review for Chapter 5. Question number 1, it says name the y-intercept and slope and then graph the inequality. Recall that on page 108 it actually said if you don't know how to go from standard form to slope-intercept form, you're going to fail Chapter 5. Well, page 107 is where we find standard form. You cannot identify the y-intercept and slope if it's in standard form. We have to change it to slope-intercept, which means we need to isolate the y. So what's our first move to go from standard to slope-intercept? Get the x on the other side, remembering to change the sign when you cross over. And so we get, don't forget the negative 3y is less than, you cannot combine those, they're not like terms, so we write them out as the expression negative 2x plus 6. Now the y is still not isolated, so we need to undo multiplication by division. And we remember Rule 2, page 37, Rule 2, page 37, which says if you multiply something to or divide something by a, sum or difference, you have to put that sum or difference in parentheses and distribute. Good. Now remember that what we're distributing is division, and there's a rule about flipping the symbol when you're multiplying or divided, so we're going to hesitate to write a symbol. We're going to have the negative 2 divided by the negative 3, and then the 6 divided by the negative 3. We need to use our sign rules. When you multiply or divide with the same sign, the answer is positive 2/3. It doesn't divide evenly, so we leave it as a fraction, which is fine with us, because that 2/3, that's the coefficient of x, is going to be our slope, which means to go up to right 3. And then we divide the 6 by the negative 3, and when you divide with different signs, the answer is negative, so we put a minus. 6 divided by 3 is 2. And then we have the flipping it rule from page 86, if you need to study that little rule. That little rule says if you multiply or divide both sides of an inequality by a negative number in the undoing process, you change the greater than to less than or less than to greater than. So we have changed it from standard to slope-intercept form. Slope-intercept form of a line is y equal mx plus b, where m, the coefficient of x, is the slope, and b, the constant added to the x stuff, is the y-intercept. And so the slope of our inequality is 2/3, and the y-intercept of our inequality is negative 2. You understand that? And then we're going to graph. So we're going to pull in a graph. And so how do we graph? You do the slope of the y-intercept first. Y-intercept. It says this thing crosses the y-axis at negative 2. So we go to negative 2 and make a dot. The slope of 2 over 3 is change in y over change in x. When the change in y is positive, you go up, because the positive direction for y is up, so it means to go up 2. When the change in x is positive, you go to the right, because the positive direction for x is to the right, so you go up to right 3. From where? The y-intercept. From the y-intercept, we go up to right 3, up to right 3, up to right 3. repetitively. There we go, up 2, right 3 repetitively. And you could reverse that, right, and go down and left, down and left, down and left, down and left repetitively. Is my line going to be solid or dotted? Where do we look to see how to do our shading and dotting? Not where we started, not while it's still in standard form, but down here where we finished writing it in slope-intercept form, right? Don't look in the wrong place for your inequality. Look at where you ended up writing it properly in slope-intercept form. And so looking at it there, we see that there's not an equal to line under the final inequality, so it's going to be a dotted line. And it says y is bigger. In which direction on the graph does y get bigger? Y don't go right. Y goes up or y goes down, and y gets bigger up because y is positive up and y is negative down. So it says y is bigger, and so we shade up from the line. Yes, you have to shade on the test. You got to get your solid or dotted right. You got to get your slope and intercept right. You got to get your shade right. Any questions on number 1? Yes. Yeah, if you want to make sure I know it's dotted and you write dotted down, that's good. That's cool. Sometimes it's hard to tell. Any questions on number 1? Okay. You got it? Number 2. Number 2 is an X only. Ding, 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 ding. What's your brain say? Vertical line. And our brain goes right into memory work. Now I'm going to write all this down again. Where all do you find your horizontal vertical rules? Starting on page 96 at the bottom, and then they're written as words 97 at the bottom, and then on page 104 at the top where we introduced to you the point slope form of a line, there's a summary and they're real nice right there. And then on page 126, the very first page of chapter 5, we actually look at graphing and shading with horizontals and verticals, and they're all there again. And then there's some examples on page 127 that we see them all again. So there's a lot of good places. If you just want some drill and practice, look at all of them and say it till you get to the end of that. And if you don't know them, go back and start the front. But you have to know your horizontal and vertical rules. What is the slope of every single vertical line? Undefined. Will a vertical line have a y-intercept? No. They never hit the y-axis. They're parallel to the y-axis. So for y-intercept on a vertical line, we put none. Any questions so far? All right. So we're going to pull our graph in when I find it. And we're going to graph. Now it's going to be a vertical line through what? X is 3. Where's x equal to 3 at? To the right of the origin by 3. Vertical line. Now don't zip it on there till you know if it's solid or dotted, right? Is it solid or dotted? It's solid because it does have the equal to mark under the inequality symbol. So it's a solid vertical line through x is 3. Do you shade up, down, left, or right? It says x is smaller. X goes left and right, the values of x are positive to the right and negative to the left. So the values of x get smaller to the left. It says x is smaller to the left, so we shade left. Any questions on number 2? Make sure you do your memory work for your horizontal vertical. Which way to shade on x's, which way to shade on y's, when is it solid, when is it dotted, and how to go from standard to slope-intercept form. Any questions on the first 2? All right, number 3. Number 3 says the solution to 4x plus 6y equal 4 and 3x plus 3y equals 6 is 4 negative 2. It gives you the answer. It's going to give you the answer on the test. And it's going to give you that same equation 4 times. And it's going to say solve by substitution, show your work. Solve by graphing, show your work. Solve by linear combination method, show your work. And then solve by matrices and show your work, except we don't have to do the matrices. Now on the test, if you say, am I doing this by the right method, I'm not going to tell you. And if you solve substitution by linear combination and linear combination by substitution, I'm going to count them both wrong. Because you're not supposed to know how to start. Now, if we're going to solve a system by substitution, what do? Put 1 in slope-intercept form to isolate the y and plug it in. If we're going to solve by graphing, what do? We put them both in slope-intercept form. So we can find both slopes, both y-intercepts, get both graphs, and find the point of intersection. If you're going to solve by linear combination, what do? You don't put either one in slope-intercept form. You leave them both in standard form and align like terms vertically. You got to know how to start, right? Okay, so make sure you know that. Again, I give you the answer, and I'm going to show you something because there's going to be people watching, but don't do this. Don't write this down. We could divide this by 2 and reduce this to 2x plus 3y is equal to 2. And we could divide this by 3 and reduce it to x plus y equal 2 before we ever start. These are not really written in simplest form as standard forms of a line. I knew that. I did it because I wanted you to mess with some numbers here, okay? We're not going to do that, but I just wanted those watching to be aware that we knew that. Yes. Yes, if you see that something will reduce, you can reduce it to make your numbers smaller to start with if you would like to. That's totally legal. You can enlarge or reduce either one, right? What we normally do in linear combination method is to enlarge everything, but there's nothing that says you can't reduce. Okay. So we just wanted to make you aware of that. That may not be applicable on the test. All right. So, to solve by substitution, what do? Isolate one variable like y, take what it's equal to and plug it in place of it in the second equation, gets you down to one variable, and you solve using the order of operations, right? So we're going from standard form to slope-intercept. What's our first move? To isolate the y. Get the x to the other side, remembering to change the sign when you cross over. This is the second time on this test that we're going through this process. And so we get 6y equal. Can you combine 4 and negative 4x? No, they're not like terms. So we write them out as an expression, negative 4x plus 4. Understand that? Everybody take notes. Some people are choosing not to. Thank you. Now the y is still not isolated, so we want to undo. We're going to undo multiplication by division. And then we have to apply Rule 2, page 37, are the distributive rules that are summed up on page 171. And so we're going to say that rule. If you multiply something to R, divide something by A, sum or difference, we're going to put that sum or difference in, parenthesis, and distribute. And so we get y is equal to, and don't forget that we're undoing multiplication by division, so we're dividing. Now 4 divided by 6 doesn't come out even, and so we write it as a fraction, but we reduce it. What is 4, 6 reduced to? It's a negative 4, 6. It reduces to negative 2/3, right? So we're going to get negative 2/3 x. And then we get another 4, 6, which reduces to 2/3 again, right? That was one of your homework problems, if you remember. I just did it about 6 times today in regular algebra. Anyway, so we're going to take what we got for y, and we're going to substitute it in place of y and solve for x. So we get 3x plus 3 times whatever y is. Now, we have times a sum. If you have times a sum or difference, you have to put that sum or difference in parenthesis. Negative 2/3 x plus 2/3 equals 6. Let's see, we got that? Now we're going to do anything we can to simplify in the order, please excuse my dear Aunt Sally, looking for distributive property and combining like terms. Now what we have is this 3 times that negative 2/3, which is 3/1 times negative 2/3, which the 3's cancel, and we get negative 2x. So we have 3x, and then the 3's cancel, and we get that negative 2x. Had an x on it. And then we got to take that 3 times that 2/3, and so we have 3 times 2/3, which is a positive 2, equals 6. At this point, if we had a denominator with one of those x's, we would multiply through by the common denominator trick. This particular example doesn't have that. The one on the test may or may not. You need to know how to use that trick from your homework in case it shows up. There will be some on the post-pack that will make you have to deal with it. We're going to continue to do anything we can to simplify in the order, please excuse my dear Aunt Sally, looking for distributive property and combining like terms. We're going to combine like terms. 3x minus 2x is 1x, plus 2 is equal to 6. We've done all we can do to simplify. The variable x is only on one side, so it's time to undo. We're going to undo addition by subtraction, and we get x is equal to 4. Now what are we looking for? The solution to the system. The solution to the system of linear equations is the one xy that makes them both true, which is the point of intersection in the graph, because solution means intersection, which means what's common to both. So we're looking for an ordered pair xy that'll make them true. We've got the x, but we need the y. How are we going to get the y? Plug that in place of x over here where the y has been isolated and solve for the y. And so we get y is equal to negative 2/3 times my x of 4 over 1 understood plus 2/3. Yes. Yes. Her question was, could you plug it back into standard form, one of the original standard forms, and solve? The answer is yes. And so we have multiplication and addition. Which one of those do you do first? Multiplication. And so we're going to get y equal. You multiply the numerators. Negative 2 times 4 is negative 8. Multiply the denominators. 3 times 1 is 3. Multiply the numbers, numerators. Multiply the denominators, names. Multiply the numbers, and you multiply the names, and you get a new name. Negative 8/3 plus 2/3. My operation now is addition. To add or subtract, the names have to be the same. In algebra, we call them like terms. With fractions, we say that we need a common denominator. We have a common denominator. When you add or subtract, the name stays the same thirds. So we add the numerators using sign rules. When you add or subtract with different signs used, and take the larger, there were more negatives. Negative 6 divided by 3 is negative 2, so my y is negative 2. My solution is the ordered pair 4, negative 2. On the test, I will give you the answer to start with. You'll know if you got it right or wrong, because I'll give you the answer. But your work has to be right. If you get in there and you make a mistake and you start manipulating stuff to try to make it look like you knew what you was doing, I'm going to count it wrong. I'm looking at your work, not your answer. Now, you ought to get the right answer. If you don't, kind of not looking very closely or something. Anyway, any questions on that? All right, number 4. Number 4, I'll get there in a minute. It says solve by graphic and show your work, the exact same equations. So we already know the answers for negative 2. We just figured that out, right? Now how are we going to solve by graphing? Got to get them both in slope-intercept form because we need to name the slope and y-intercept of both of them, right? Because we use the slope and the y-intercept to graph with. And what are we going to be looking for graphically to find the solution? Graphically speaking, what's the solution? The point of intersection. All right, so we're going to go from standard to slope-intercept. Our first move is to get the x term to the other side, remembering to change the sign when you cross over. And so we get 6y equal negative 4x plus 4. And yes, I want you to show the work again when you go to graphing, not just write it from the first page. And so now we're going to undo multiplication by division. When you multiply something to or divide something by a sum or difference, you have to put that sum or difference in parentheses and distribute. And so we get y is equal to negative 4 divided 6 reduces to negative 2/3 x. 4 divided 6 reduces to 2/3. Yes. Both, because we have to graph them both and find the point of intersection. Now, you're going to get some ugly y-intercepts, even on the test. If you get something like 5/3 for a y-intercept, what are you going to do to figure out where to put it on the graph? Change it into a mixed numeral, right? We let you write answers as improper, but you may not can use them improper. You may have to change them to mixed numerals to see where to put it. Now you realize there's going to be some estimation of where these things go. If you're off a little, that's okay, as long as your work's pretty up here, you see? So what is the y-intercept of this? What's added to the x stuff, 2/3? What is the slope? The coefficient of x, which is negative 2/3. Understand that? Now I'm going to go ahead and graph that one, I guess. My origin is there. Does that look like it to y'all? We'll call it good. Now, the y-intercept is up 2/3. If I took that and made 3 pieces out of it, which I didn't, then that's hard to do, actually. Where did my origin go? We'll call it that. So 2/3 is somewhere in there, right? That's my y-intercept. Then my slope of negative 2/3 means to go down 2, right 3 from the y-intercept. Now if I'm going to go down 2, I've got to be in that same position 2 bars lower, right? So down 2, and then to the right 3. And then I'm going to be in that same position 2 bars lower, down 2, to the right 3. You understand we're estimating where 2/3 is. Same thing, 2 bars lower, down 2 to the right 3. Down 2 to the right 3. Little bit tedious with fractions. We could do the opposite, up 2. So same position 2 bars higher, to the left 3. Up 2, same position 2 bars higher, to the left 3. Same position 2 bars higher, to the left 3. You understand that? That wasn't too bad. It's going to be this way on the test. You just have to do the best you can graphing. Solid or dotted? Solid. Any shading? Nope. Just a line. Who knows if this is going to hit or not? Should have gone the other way. Just make it fat. That always works. All right. They said we got that one. So we need to do the other one. So we're going to isolate the y, so we need to move the x term to the other side, remembering to change the sign when we cross over. So we get 3y equal negative 3x plus 6. You couldn't combine the 3 and the 6 because the 3 had an x on it. They're not like terms. We're now going to undo multiplication by division. If you multiply something to or divide something by a sum or difference, we put that sum or difference in parentheses and distribute. Rule 2, page 37. And so we get y equal negative 3 divided, what's 3 divided by 3? 1. So it's a negative 1 understood x, so negative x. And then 6 divided by 3 is 2. So what's my y-intercept? 2. What's my slope? Negative 1 over 1 understood, which means to go down 1, right 1. Now if you're going to write your answer for slope, make it a negative 1, because that's not simplest form to say negative 1 over 1, but if you're writing it to be able to read it, then you want to do that, okay? All right, so we're going to graph the y-intercept, which is 2. So we would go up 2, make a dot from the origin. We do our slope from there, which means to go down 1, right 1. So down 1, right, whoops, I missed. Down 1, right 1, make a dot. 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 Down 1, right 1, down 1, right 1, etc. R, up and left, up and left, up and left, up and left. It's a solid line. Those leaning to the left ones are harder for me to draw than the ones that are leaning to the right, because I zing it like that. See? All right. Did they actually hit at this point? Did they have that exact common point? Well, we know where the answer is. The answer is 4, negative 2, right? 1, 2, 3, 4, negative 2. Because I already gave you the answer. They should have hit right there. You can see I didn't do a very nice job of graphing with my lines. It's kind of hard to do at that angle. And anyway, so you're going to estimate the point of intersection. Now that shouldn't be hard to do since I already gave you the answer. I would suggest on the test that if your point of intersection is not anywhere in that vicinity, that you might look at how you changed them to slope-intercept form. You may have messed up. If you're somewhere close to that vicinity, then we're going to call it good, realizing that graphing is not the most accurate method of solving a system. Substitution, obviously, was more accurate. Any questions on number 4? So we solved this system by substitution. We now have solved it by graphing, and then we'll solve the same system by the linear combination method. Everybody ready to move on? All right. We're skipping matrices. I missed the other one. I must have hit too many buttons. I guess it's at the bottom. There it is. Couldn't find it. Solve by linear combination and show your work. To solve a system of equations by linear combination method, you leave them both in standard form and align like terms vertically. That's already been done for us. And then we're going to produce opposite coefficients of one of the variables, which is what? Additive inverses, opposite signs. The additive inverse numbers will be the what? LCM of both. Now, you can decide, do you want to cancel the x's or the y's? Y's. So, it was said that we want to cancel the y's. If we want to cancel the y's, then we need to multiply through by whatever it takes to make additive inverse y's. The additive inverse y will be the least common multiple between the present y's, right? So we want to find the least common multiple between 3 and 6, which is 6. The smallest thing they'll both go into like a common denominator. If we wanted to go through all the work of doing it, then how would we do that? You do the prime factorization, write it in exponential form. The prime factorization in exponential form. You take the largest power of each prime involved. Largest power of 2 is 2 to the first. Largest power of 3 is 3 to the first. And multiply those. There's the LCM drill to get that number. The prime factorization of 6 is 2 times 3. So you write the 6 as the product of its primes exponentially 2 to the first times 3 to the first. And then we look at what primes are involved. The primes involved are 2's and 3's. 2's and 3's. We take the largest power of each prime involved in all that. The largest power of all the 2's is 2 to the first. The largest power of all the 3's is 3 to the first, and you only take it once. If there had been a 3 to the fourth, we'd have used the 3 to the fourth instead of 3 to the first. If one of those had been 3 to the first and one 3 to the fourth, we'd have used the 3 to the fourth. You take the largest power of each prime and multiply. This is on page 8 of your textbook. If you're bumfuzzled, then go there and look and study that, and they'll answer your questions. Yes? No, you don't have to show that work. But you need to know how to do that work for the big uglies, right, that are coming at us later on. All right. So, we want to produce a 6 and a negative 6. Does it matter whether I put, which one I put on top or bottom, positive or negative? No. So now what do we do? Right. Multiply through by whatever factor is needed to accomplish that. Multiply through by whatever factor is needed to accomplish that. So to do that, we've got to figure out what factor to multiply by, right? So how do we do that? We look at what we got and look at what we need. And we think 6 times what will give me that 6? 1. So we'll multiply through by 1. And then we think, here's what I've got. Here's what I need. What do I multiply what I have by to get what I need? 3 times what gives me negative 6? Negative 2. You understand that? So we multiply through by whatever factor is needed to create additive inverses. Okay? And so we're going to get 1 times 4x is 4x. 1 times 6y is 6y. And 1 times 4 is 4. Multiplicative identity. You multiply by 1, it keeps its identity. Negative 2 times 3x is negative 6x. Negative 2 times 3y is negative 6y. Negative 2 times 6 is negative 12. So we have created additive inverse y's by multiplying through by the factors that we needed to accomplish just that. Now that we have additive inverse y's, we can combine these lines using sign rules, and that variable that we produced additive inverse coefficients for will cancel out. When we combine our x's, the signs are different. When you add or subtract with different signs, you subtract and take the larger. There were more negatives, so it's a negative 2x. My y's are additive inverses. They cancel. I look at my numbers, my c's. When you add or subtract with different signs, you subtract and take the larger, which was negative. Now we undo multiplication by division, and we get x is equal to 4. But what are we really looking for? That one point xy that makes them both true, which was the point of intersection in that graph up there, because it was the same equation, right? So what are we going to do to get the y? Plug it back into one of the originals. The first original was 4x plus 6y equal 4. We're going to plug what we got for x back in place of x and solve for y. So we get 4 times x, which is 4, plus 6y is equal to 4. We're going to do anything we can to simplify in the order. Please excuse my adherence, Sally. So we can do the multiplication. To simplify, we get 16 plus 6y is equal to 4. We cannot do anything else to simplify. The variable y is not on both sides, so now it is time to undo. The 6 is being multiplied and the 16 is being added on because it's positive. We're going to get rid of addition first by subtraction, and so we subtract 16, and I'll shift it over. We'll get 6y is equal to negative 12. That's a positive, that's a negative. When you add or subtract with different signs, you subtract and take the larger sign. Now we're going to undo multiplication by division, and we get y is equal to negative 2. So my solution is 4, negative 2. We took this one system, we solved it by substitution, and then by graphing, and now by linear combination, and we got the same answer all 3 times. That'll be the same way it'll be on the test. Yes? You could cancel the x's, not the y's. Yes, you could cancel the x's, not the y's, and get a 12, negative 12. It doesn't matter whether you cancel your x's or y's to start with. Any questions on that? All right, very good. Okay. Were you done? Everybody done? I can bring it back. Good. Okay, here we go. Matrices we're skipping. Number 7, 8, and 9 are parameter changes involving parallel and perpendicular lines. What are the rules that we had to memorize to get this done? Page 132. Now the lesson is on page 135, and the homework was 135 to 136. The lesson is on page, I'm slipping now, 134 maybe, who knows, I think it may be, oh, who cares, oops. Okay, the memory work is on page 132. That's where it says parallel lines have equal slopes and never intersect. Perpendicular lines have inverse reciprocal slopes, meaning flip it and change the sign, and they intersect at 90 degrees. So parallel lines have equal slopes and never intersect. Perpendicular lines have inverse reciprocal slopes, meaning flip it and change the sign, and they hit at 90 degrees. Now the lesson's somewhere in the vicinity of page 135, but the memory work for those rules is on page 132. All right, here we go. We're going to run the drill the way we ran it in class. How do we run the drill in class? Well, we're going to stop right there, and we'll begin this recording again with the next session. You might want to study page 132 before then.